Question 4b1 wants us to prove that sine theta plus cos theta plus 1 over cos 2 theta is equal to cos theta over cos 2 sine theta. Now let's start with our left-hand side, which is equals to sine theta plus cos 2 theta plus 1 over cos 2 theta. Now, whenever you're working with proving, you always want to first simplify to the simplest identity that you have. But not only that, you want to also see if you can get rid of some of the things, right? So, unfortunately or fortunately for us, sine 2 theta only expands to one identity. And for our cos 2 theta has two identities. We can have one where we have 1 minus 2 sine theta squared. We have one where it's cos 2 theta squared minus 1. In this case, and also the cos squared theta minus sine squared theta. In this case, the cos one would make much more sense. The cos where it goes with its negative 1, it makes sense. Reason being, we want to get rid of that extra 1, and that extra cos over here will allow us to take out cos as a factor, right? So we didn't use the sine 1, and also the sine 1 wouldn't get rid of that minus 1. Then at the bottom, we also look for clues in the answer in itself. So you can see what they already have there, and you can see which identity they used to replace that one, which would have been the cos squared theta minus sine squared theta. Okay, continuing on, these two will then go ahead and cancel each other out. Plus 1 minus 1 will give us 0. And on this one, we can take out cos as a factor, or 2 cos to be more exact as a factor. So 2 cos theta, and we would be left with cos theta plus sine theta, sine theta plus cos theta. Already we have something in the works that looks a little bit like the answer we are looking for, but we need to get rid of that. Now, the bottom part here is a perfect square. So that means that we can have a bracket that says cos theta plus sine theta and cos theta minus sine theta. Okay. And we're happy because this bracket can get rid of that bracket, and we'll be left with 2 cos theta over cos theta minus sine theta, which is equals to the right hand side.